Welcome to Homework Lib.
Hi. So over here we have the following refraction experiment in which we shine yellow light with a wavelength of 550 nanometers to a surface of water at an angle of 48 degrees, and we're told that the refractive index of vacuum is equal to 1, that we are going to approximate that of air as that, and that the refractive index of water is equal to 1.33. With this information, on the first part, we want to determine the frequency, the speed of light in water, and the wavelength of the light in water. So, in order to do that, the first thing that we need to remember is that when we go from one medium to another, the frequency stays the same. What is going to change is going to be the velocity of the wave and the wavelength of the wave. And those changes are going to be according to sine of theta 1 over sine of theta 2. This is going to be equal to velocity in medium 1 over velocity on the second medium, and this is going to be equal to lambda 1 over lambda 2. In a similar fashion, we can go ahead and do the calculation of the angles according to Snell's law that tells us that n1 sine of theta 1 is going to be equal to n2 sine of theta 2. So with this information, the first thing that we're going to do is calculate the frequency, since we know that it's going to stay the same. In order to that, remember that whenever we have a wave, we know that the velocity of the wave is equal to lambda over t, which is the same as frequency times lambda. So the frequency is going to be the velocity of the wave, that is equal to c, and c is equal to 3 times 10 to the 8 meters per second. The frequency becomes equal to c over lambda, 3 times 10 to the 8 meters per second, divided by 550 nanometers, which is 550 times 10 to the minus 9 meters. The result of this is going to be equal to 5.45 times 10 to the 14 hertz, which is equal to approximately 0.55 petahertz. Remember that the peta prefix is going to mean 10 to the 15, right? So we have our first result with frequency. Now for the other two, we can know the velocity of water from the definition of the refractive index, which is going to be equal to the speed of light divided by the speed of light in that medium. So from here, in the case of water, we can get that the velocity of light in water is going to be equal to c divided by n of water, which is 3 times 10 to the 8 meters per second, divided by my refractive index, that is 1.33. As you know, the speed of light, whenever it changes to a medium that is not equal to the vacuum, it is going to decrease. So the result that we get here is 2.256 times 10 to the 8 meters per second. We know the frequency, we know the velocity of the water, so we can directly know the lambda, right? Because lambda is equal to velocity over frequency. The velocity of the wave is equal to 2.256 times 10 to the 8 meters per second, which is approximately 225,000 kilometers per second. You can do that conversion simply by multiplying by the conversion factor, which is dividing by 1000. Okay? Over my frequency that we said that was equal to 5.45 times 10 to the 14 hertz, which is second to the minus 1. The result is going to be in meters, 4.138 times 10 to the minus 7 meters, which is approximately 414 nanometers. So we have frequency, we have the velocity of light in water, frequency, velocity of light in water, and the lambda of the yellow light that would have in water. And finally, we're going to go with part B, which asks how much the direction of the light beam changes when it travels from air to water. And in order to do that, we're going to apply directly Snell's law. N1 sine of theta 1 is equal to N2 sine of theta 2. We can know what is going to be the sine of theta 2, which is N1 sine of theta 1 divided by N2, giving the index of air, or in this case vacuum, divided by the index of water, multiplied by the sine of my angle in the experiment that was 48 degrees. Which gives 0.55587 with a couple more fives. And if we take the arcsine of this quantity, 8755, what we get is equal to 33.97 degrees, which is approximately 34 degrees. So that is how much the light is going to deviate from the normal in water. That is the angle that we found here. Theta 2 is 34 degrees. So with that, it would be all. Thank you very much and have a good one.